Hey guys, Josh with Dead Channel, and today what we're going to be talking about is an engine that, frankly, I'm surprised I haven't made a video about yet. I've made pretty much videos on every cat diesel engine made in the 80s, 90s, and 2000s, but somehow this one missed the mark. Now this one also led to my favorite engine, the C13, and for its time was a revolutionary engine. It was the first cat diesel engine that was designed from the ground up to be an electronic engine. First, to use the electronic unit injector system, it had a two-piece cylinder block, part of which was aluminum, part of which was cast iron. It had no cam bearings. Weird engine. And probably the reason I haven't made a video on it yet is out of all the engines that I've made videos on, it's probably the least one that I've ever worked on. And for its time was a very popular engine. Maybe not the best for reliability's sake, but it was very common, and you still see them, but I haven't worked on that many. Luckily, I do have two people that have contributed their opinions that have worked on a lot of them and worked on them when they were new. So luckily, we have that info to go on. And if you don't know what engine I'm talking about, it's the Cat 3176, which ties in with the Cat 3196. So let's discuss it. So let's start with the basics. The Cat 3176 was an inline six diesel engine. It was a metric engine, meaning it used metric fasteners, basically metric measurements for pretty much everything. It was a 10-liter engine. The bore was 125 millimeters with a 140 millimeter stroke, and its sister engine was a 12-liter engine, a 3196, but basically used the same block, spacer block design, which we'll discuss in a little bit, and cylinder head design. It was a pushrod engine, so the camshaft was ran by the crankshaft, pretty much like every engine, but used push rods. The camshaft was in the block. Push rods ran up to the head, which used a rocker arm system. And this was the first cat engine that was designed to be a MUI, a mechanical electronic unit injector engine. Now, they ended up using that style on all its predecessors, or not predecessors, all of its engines that it turned into. So the C10, C12, C13, C11. Also, the 3406 at the time turned into 3406E, which used the same fuel system. They ended up using a MUI system on those. Even the big engines, like the 3500 series engine, ended up using that style of fuel system. This was Cat's first, we'll say, putting their toe in the water to see how the system would work. Now, of course, there's problems anytime you have something very new, and this fuel system relied on electronics, and electronics, folks, in the mid and late 80s, not that great, and a lot of problems came with that. Before we get into problems with the engine themselves, we need to discuss some other design features of it before kind of telling what all the problems that they had with them were. The first was kind of Cat's weird naming system for engines at this time. So of course you have the 3406 engine, which everyone knows. That ended up turning into the 3406E, and that turned into the C15. But the displacements is Cat started kind of using the name of the engine to refer to the displacement. So what do I mean by this? So a 3116, the 3116, the 1 is 1.1 liters per cylinder, and that's a 6-cylinder engine, so it was a 6.6 liter engine. There's a 3126, which was basically what took the place of the 3116. That was a 7.2 liter engine, and that was 1.2 liters per cylinder. The 3176 held this same naming principle. So it was 3176. It was a 1.7 liter per cylinder engine, and then its sister engine, the 3196, was a 1.9 liter per cylinder engine. Now, that's how they turned into basically the C10 and C12, because they were a 10 liter and a 12 liter engine. So why was this engine developed? That's a pretty good question, and one I'm not really sure what the answer would be, because to tell you the truth, Cat already had two other 10 liter engines, diesel engines, at the same time. So this was the third diesel 10 liter engine they were making. And its claim to fame was it could make more power than the other inline 6 10 liter, and it weighed a little bit less. Now, the one I'm comparing it to is, of course, the older 3306, which had been around for a while already. It was developed, I believe, in the early 70s, and this was the late 80s. So why would they make one that is comparable in power, I would say? Here's the specifications. it could make a little bit more power, and it weighed a little bit less. And the way they made it weigh a little bit less was our friend aluminum. Now, what do I mean by our friend aluminum? Well, what they did is basically they cut the top part of the block off. I mean, they didn't cut it off. They formed it to be missing the top part of the deck. And then they had what they called the spacer deck, or some people call it the cam box. It's actually a separate piece that went between the cast engine block and the cylinder head. Weird. I understand why they did it to save some weight, but it adds so much more complexity to the system. Not only do you have dissimilar metals, you have cast iron, aluminum, and then cast iron, of course, in the cylinder head again. Kind of weird. I'm not sure why they wouldn't just go with an aluminum cylinder head at this point instead of making this two-piece block, but for whatever reason, that's what they decided to do. So was it lighter? Did it make more power? Yes. I would say, though, it didn't make a lot more power, and it wasn't much lighter than the 3306. Now, maybe Cat's idea was, look, the 3306 is an older engine. It uses standard fasteners. It's not designed to be electronic. We'd have to retrofit it somehow. Why don't we start from scratch? I don't know, folks. I wasn't in the meetings, but that's what they ended up doing. Now, one thing you do need to realize is, though, Cat had an engine that was capable of making more power and already weighed less and was a 10-liter. If you don't know what engine I'm talking about, 3208, which was an V8 8-cylinder diesel engine. Now, you might be saying, well, 3208, does that mean it's a 2-liter per cylinder? Well, no, that'd be an 8-cylinder with a 2-liter. That'd be a 16-liter engine. The nomenclatures with the 3100 series, with the 3116, 3126, 3176, 3196, really none of those hold true with any other Cat engine, so I'm not really sure why they came up with that system. You might also think that the 3100 series are all the same block or same design. Totally different. 3116 and 3176 have basically no interchangeable parts. And the naming system doesn't apply to any of their other engines. So a 3306 isn't a 3-liter per cylinder. 3406 isn't a 4-liter per cylinder. Not sure why they stuck with that. But they did go way with it after the 3176. So, don't know. Let's discuss some of the other weird design features that they stuck with this engine. And then we'll discuss the problems that kind of led to. So, of course, all engines have problems, folks. As my buddy Dale said, we wouldn't have jobs if all engines didn't have problems. So 3176, new design, new block, everything. Totally interesting design, I'd say, in some of their features. So one thing I mentioned in the intro was there were no cam bearings. You could put them in after if you had a failure, but the spacer deck, being aluminum, basically acted as the cam bearings themselves. So the cam sat in the spacer deck, and then oil was supplied directly to the cam journals through the spacer deck. Kind of a weird design. Also, according to Cat, coolant wasn't going between the block and the spacer deck and the head. It basically passed directly into the spacer deck and then into the head. Interesting design. The liners themselves were what they call mid-mount liners. They weren't like the 3306 or 3406 where the liner flange sits on top of the deck. They actually sit mid-mount in the spacer deck. And that is held true on the C10, C12, C11, C13, although those, they got rid of the aluminum cam box spacer deck design. They went to a single block piece, which I think was a very good idea. Now, they also had some carryovers from the time, like copper injector cups, which are a big pain in the butt if you've ever had to replace them or mess with them on the 3116s. Steel ones are way better, in my opinion. Now, one of the other problems, folks, is this was early electronics, super early. This was the first version of basically all the electronic engines that Cat made, and that created some problems. So the early electronic engines, and what we're talking about here is serial number ranges 2YG and 7LG. It then went to a 3176, which was a 9CK serial number range. But the early ones, they used the very early control modules that had fuel going to them, and basically they weren't really flashable like a modern Cat ECM is, where basically just with software you program the ECM. On these, they had what they call a personality module. Now, modern Cat ECMs also have personality modules, but those are programmable. These are actually a removable part, and these parts are apparently hard to get. According to John Goldsmith, he had sourced out the module and the actual ECM itself. He said it costs about $8 $8,500. $8,500 for the brain box, the electronics. I mean, your cell phone probably runs a lot better processing system than these early engines did, but they cost so much now if you need to get electronics for them, which is kind of a problem. One of the other problems John Goldsmith said was the early ones, not the later. They did go to a 40 pin similar to the 5EK 3406 ECM. The early ones, he said, could actually, as he's seen several times, they would leak fuel. They could leak fuel externally, or it could actually leak into the ECM and then fry the ECM. That's a big problem, folks. I mean, you don't want your computer leaking diesel fuel out of it. You know, that's not a common problem you want to have. Now, folks, we've discussed a lot of the features that make this engine kind of unusual itself, but I think what we need to do is we need to listen to a couple first-hand accounts of these engines themselves. And what I've got is I've got a pretty long article from John Goldsmith, which if you don't know, he's always in the comments section. He knows way more about these older engines than I ever will. And he was around when they were new. So let's read his email, and he's got some interesting anecdotes about them and stuff that probably most of you don't know. And we'll also read my buddy Dale's email, because he also worked on them when they were new, and they both have very different perspectives on them. I think you'll find them interesting just to see from the time and the different perspectives what they think of these interesting cat engines. So here's a letter I got from John Goldsmith. Thank you, John, for sending this, by the way. And the first starts off with, the 3196 was not in a truck, and that's true. It was only an industrial and an equipment engine. 3176, however, I called it the Yellow Edsel. The first ones were a 2YG prefix. Engineers told CAT it was not ready to be released. The VP stated, "We have a deadline, release it." I was told he no longer works for CAT. My old boss quit CAT and went to work for a trucking company. They purchased 5 of these. I asked, "How long do they last?" His reply was, "Every 9,500 miles, they are towed into a shop." However, it was the lightest weight to horsepower ratio of any engine ever built. CAT stopped production for 6 months after it was released. When one came into the shop, CAT had a 1-800 phone number you had to call. You'd enter the last 5 digits of the engine serial number. You got a voice message on recalls to do. So you circled/marked which recalls on a 52-page recall list. The alpha numbers went from A to Z and then Z1 to Z6 as they ran out of letters. That's pretty sad. A lot of recalls were minor, but some required to replace the pistons. The engine had no cam bearings. Camshaft runs on an aluminum spacer deck. Between the block and the spacer deck are O-rings. Most are for oil supply or return. One is for the air compressor coolant. It's a yellow O-ring on first production. The EIU cups, electronic unit injector cups, would split, and these were of copper design, and fill the cooling system with diesel fuel. The O-ring could swell and start leaking. To replace the O-ring, you had to remove the cylinder packs, radiator, engine camshaft, finally the spacer deck. OPTs currently requires there to be replaced at time of overhaul. The camshaft gasket was prone to leak oil as well. When you put the liners in, CAT stated to put the CAT red glue sealant around the liner seal area to the block joint. Also, if it has to be counterbored, the spacer deck has to come off. Since the EIU sleeves are copper, that have to be reamed on the seat. If they can't, you have to drain the coolant, remove the cups, swedge it back in the block, and ream it, much like 3116 engines. The first engine had no shield around the camshaft. I have seen a new engine come in for its first valve adjustment. Push rod jumped out and came out the side of the spacer deck. CAT sent him a brand new engine. If the ECM, the TDM, and PM fail, parts are $8,500 if you can get a PM. The PM is a personality module. Timing has to be calibrated with an ECAP and timing indicator group. I'm going to stop it right there. So an ECAP, if you don't know, before CAT ET, they had this electronic control, basically apparatus that would plug in. It was an early computer to talk to these early computers themselves. I've seen a couple of them. I think I've only used one ever once. Very expensive to get still and really clunky, but there's no way to backward compatible on these early ones as far as I know. So it's kind of a lost thing to technological history. But let's get back to John's email here. The camshaft timing ring was bolted on. Have seen it put on backwards. Also, it could wrap or warp and lose RPM signal. The air compressor and power steering drive gear were too soft and would wear the air compressor and power steering pump splines. Engine would whine when running. The EIU tips would split. Cat sent to the dealer a stock box full of electronic unit injectors to replace a set on failure. If the oil cooler fails, you have to replace every part from the water pump all the way to the plate that bolts on the spacer deck. That plate is held with about 20 bolts, so the turbo and a lot of the side of the engine has to be removed. I've seen a couple engines with a large transmission, no rear support. All that weight and flexing would break the flywheel housing, all serial number ranges. Water could get into the ECM via the fresh air hose or in the TDM via the boost hose. As the fresh air was open inside, the ECM, TDM, and PM could fail from water damage. That was the first series. So then came out with the 7LG. Some improvements were made, not a lot. Last 3176B, which is a 9CK serial number range, went to the 5EK style 40-pin ECM, and all the electronics were updated. Had a memo from CAT stating to be aware of leaks on the engine, including but not limited to loose bolts, warped housings, clamps, gaskets, and seals. Biggest problem on these was the very front or rear head bolts would break. Weld the bolt out, replace the 4 bolts. Hope head gasket is not blown. This is the short list of problems. Well, that is quite the exhaustive short list, John. But Dale had a very different outlook on the 3176, so let's read his email. I found that very interesting. So Dale writes about the 3176. I entered into working on these engines about in the middle of their production run. Rick, a friend of his, worked on them from day one. He said that the very first of the 2YG engines had a 2-page list of updates that he had to perform on all those early engines. The one I remember is the update of the factory head bolt holes. They were not drilled and threaded deep enough. Don't recall the serial number range and cutoff. From that point, Rick said they were pretty good engines for being cats. First full authority electronic engine. Systems Transport had a lot of trucks powered with them in particular, as well as others. I saw the 2YG in their second life cycle, with new owners after the major companies were done with them. They had somewhere around 500,000 miles on them. I had no formal training on this engine, and that came from the school of hard knocks and the daily grind. They were definitely a learning experience coming from the DD 2-strokes, Detroit Diesel 2-strokes. However, 3176 should have been the 4-stroke engine that DD should have made to replace the 92. I despise the DD series. We'll just leave that word out. I had the opportunity to work on 3176 and the Challengers. Those are the cat tractors, as well as the trucks. Its best feature was its power to weight ratio. While the engines had their issues, they all do, or we would not have a job, I consider them to be a very good option in their time. I wish we could revisit the aluminum cooling jet now, with up-to-date engine aluminum materials we have today. They were an acquired taste, though, but once you got on them, they were a piece of cake, both mechanically and electronically. I learned in short order the proper way to pursue engine power and performance complaints after documenting said complaints. Go into the computer with the ECAP. All we had then, ET wasn't out yet, and look at the factory set parameters. Then go in and look at the customer program parameters. A lot of times the programming was the reason the engines didn't run like the operator/driver thinks it should. For example, the progressive shifts on the mechanical side, troubleshooting without a code. You may find truck is gear pound. The PPM calibration is off. I spent a morning working on a Kenworth we had for equipment hauling, 3176, 9CK serial number with a 10-speed. Driver hated the truck, but changed his mind after I went through the settings, both sides of the equation. Reset the PPM, turn on droop, change the RPM setting, change FLS and FTS. After his first trip, he said it was an entirely different truck. He was very happy, just short of giving me a big hug and a kiss. One thing that's very important to know is the 3-cylinder cutout built into the factory programming. Under light load conditions, below 1600 RPM cylinders, 4, 5, and 6 will not receive command to fire. This was to reduce engine vibration and extend engine life. I can tell you because we did it, that though the engineers designed the engine around 8 to 10 speed gearboxes, I can testify that putting in a 14613 which is a type of transmission, makes it a workhorse specifically if you intend to run 105,000 gross weight. A lot of owner-operators surprised when that truck could all of a sudden, out of the blue, kept up pulling the hill, loaded out of Central Ferry, Washington. Trans-swap, a lot cheaper than buying another truck with a bigger engine. The 8-speed in it, rebuilt, so we exchanged it to a 14.613. Upcharge was waived because 8-speed cores were in high demand. So if I may suggest, overall, the 3176 was a very capable, from my perspective, at the time. It was not a victim of continuous destruction like the DD 8.2. Sure was fun and exciting that time when we put a 3176 truck engine program into a Challenger tractor. Anyway, hopefully my experience and thoughts combined with John's, along with 3176 intro review, give you enough to compose the video. Sure would be interesting to hear John's thoughts on the 3176 opposed to my thoughts. He may say I need medication, but put away in a rubber room as always, open to discussion. Thanks, bye. So that's pretty much our discussion on the 3176, folks. A very contentious, different designed engine that Cat was kind of leading the market with there. You, as the watcher, do you have any experience with the 3176s? Do you own one? Still running one? Good, bad experiences? Like I said in the beginning, I haven't worked on a ton of them, but I find it to be quite an interesting engine. Of course, Cat discontinued it eventually. They turned them into the C10 and C12. They got rid of the aluminum spacer deck, and then those turned into the C11 and C13. Cat's still making the C13 to this day. Now, Cat is also in the design phase of releasing the C13D, which I made a video on, which is a totally new engine to basically take the place of this one, but thought it would be an interesting video. Hope you guys enjoyed it. Thanks for watching.